What's up, guys, and welcome to Math Walkthroughs with Mr. Weeb. Today we are looking at representing numbers using powers of 10. Our first question asks us to write each number in expanded form using powers of 10. For the first one, we can see we have to represent that 4, but it's not just a 4, it's actually 4 groups of 10,000. So I'll write something like 4 groups of 10,000, but I can write 10,000 by using a power, which is 10 to the power of 4, because it's a 4 with 1, 2, 3, 4 zeros after it. Simple as that. Then I'm just going to add the next number, which is a 2. But it's not just a 2, it's a 2,000, 2 groups of 1,000. So I'm going to multiply it by 10 to the power of 3, because it's a 2 with 3 zeros after it. 1, 2, 3. Or 3 place values after it. Okay, then I'm going to add the next one, which is a 1 times 10 to the power of 2, because it's just one group of 100. And that's it. Let's keep going. Next we have 5,312. So it's just 5 times 10 to the power of 3 plus 3 times 10 to the power of 2 plus 1 times 10 to the power of 1 plus 2. That one spot doesn't need any powers of 10 behind it. Next, letter C. We have 10,000, but it's 1 times 10 to the power of 4. So it's one group of 10,000. We have 10,000 there. Plus, we can skip those next two place values. We can skip the thousands and skip the hundreds, go straight to the tens. 3 groups of 10, which is 10 to the power of 1 plus 4. That's it. Next, we have 1,003,145. So 1 million can be represented like 1 times 10 to the power of 6. It's a 1 with 6 zeros after it. Plus, we can skip the 100,000s place, the 10,000s place, we can go straight to the thousands. 3 times 10 to the power of 3 plus 4 times 10 to the power of 2 plus 5. Then we have write each number in standard form. So now we're going the opposite way. So here, when we look at the first one, we can see that we should have a 5 in the thousands spot, because 10 to the power of 3 is 1,000. So that's our biggest number that we have. So it's a 5,000. And then our next number is, we'll have a 3 in the hundreds spot. So in the hundreds spot, we put a 3. 5,300. Now you'll notice there's nothing times 10 to the power of 1. So we don't have anything in the 10 spot. So I'm just going to write that in black. There's nothing in the 10 spot. And then finally, we have our ones, which I will just write also in black here. 5,306. Okay, next one. We have, in our largest spot, we have 3 times 10 to the power of 6. 10 to the power of 6 is a 1 with 6 zeros, which is a million. I have 3 groups of a million. So my first number should be a 3, but I know that there's going to be 6 spots after that. We're adding 2 times 10 to the power of 3, which again is 1,000. So now I know that I have nothing in the 100,000 spot, and I have nothing in the 10,000 spot, and now I have a 2 in the 1,000 spot. Finally, I have this last one. I have 7 times 10 to the power of 1. So I know that I have nothing actually in my 100 spot, because 10 to the power of 2 is 100. So I actually don't have anything. I don't have anything in the 100 spot, and I have a 7 in the tens spot. So I'll put my 7 in the 10 spot, and nothing in the zeros or in the ones column, so I'll put a 0 in the ones column. So it's 3,002,070. And that's it for that page. Let's move on to the next. The next question asks, a number meets each rule. What might it be? Write the number in standard form and expanded form. There are 2 powers of 10 in the expanded form. Well, it could be a lot of things, but let's have a look. If there are two powers, I need it to be at least 100, because then I can have some number times 10 to the power of 2. So why don't I just do 2 times 10 to the power of 2? So that's going to be 200 plus, let's say 3 times 10 to the power of 1 plus 4. And that is the same as saying 234. And let's see, does it fit all of the clues? There are two powers, yes. So if we look at, there should be two powers, right? Here's one power, here's one power, and here's the other power. And then we have written it in both standard form. We've written it both in standard form and we've written it in expanded form. Let's go on to the next one. There are 3 powers of 10 in this one, each multiplied by different numbers in the expanded form. Okay, 3 powers of 10. That means we have to go 10 to the power of 3, which is 1,000. This number has to be at least 1,000. Okay, we can do this. Let's have 3 times 10 to the power of 3. So we've got 3,000 plus, we need at least 3 powers, huh? Okay, plus 4 times 10 to the power of 2 plus 2 times 10 to the power of 1. I've made sure that each of these 3 numbers that are being multiplied are different, right? Because that was the clue. And so in the ones spot, I think we'll just add 1. 3, 4, 2, 1. So we should have 3,421. And let's see, does this work? Are there 3 powers of 10? Here's 1 power of 10, 2, 3. Yep, that works. Are they multiplied by different numbers? Let's see, here's a different number. 3, 4, 2, 1. They're each different. And we've written it both in the expanded form and standard form. It checks off all of the things that we wanted to do. Finally, which of these numbers includes 4 times 10 to the power of 4 as part of its expanded form? Okay, 10 to the power of 4 looks like a 1 with 4 zeros after. So 4 to the power of 10, 4 times 10 to the power of 4, my apologies, I said it wrong. 4 times 10 to the power of 4 equals 40,000. 40,000, right? So which of these numbers includes 4 times 10 to the power of 4 as part of its expanded form? Well, it's not this one. This one doesn't have a 40,000. It can't be this one. This one doesn't have a 40,000. This one doesn't have it. So it has to be this one. That's it for today. Thanks for watching.